My talk here is about building NLQ for Apache Druid, NLQ standing for Natural Language Querying for Druid, and in this talk as this process I leveraged Amazon, Bedrock, and Claude. So this is me. I'm a software engineer at Imply Data. I work on the services and Druid for Imply's SaaS offering of Druid, Polaris, and I have over 10 years of experience as a software engineer. So the first question most people have is, what is NLQ? NLQ stands for Natural Language Querying. It is the idea of allowing users to interface with a database using natural language rather than, in a conversational natural language, rather than writing a query using a language like SQL itself. And here in this example, which user most recently purchased socks? Here's a select user from orders where item equals socks, order by time, descending, limit 1. So that's a quick thing, and as part of this, we leveraged some other tools for that. The goals for when I built this ability to translate natural language to SQL was to create a starting point to make a SQL query. Because not every single person knows every ins and out about SQL, and not everyone is a Druid expert and understands some of the concepts you need to know. And the key thing here is human in the loop. We do not want to take your actual natural language and query against the database itself. We want to generate the SQL for you to actually query. And so you can edit it, make changes as you see fit, and everything like that. And then the other goals of this were to expand the audience that can do data analysis. It'll just enable people to write more complicated queries. I was working with a PM who said, like, wow, this thing could actually write queries that I can't even write right now. It also saved time for developers because you do not have to think about how to do as many SQL things. And the other goal for this was fast turnaround time for both developers writing SQL queries and also for me building out the service. It's more POC rather than a full-fledged service in of itself. So what we built here, I'm going to write a query against the Wikipedia edits database. You can see, or data source, you can see all the different columns in there. And I'm saying find the number of distinct Wikipedia users per hour by region that is in Europe. It's running right now. I click the submit. It's translating underneath the hood. And you can see here, it generated a SQL query that you can run. And the cool thing that this did in of itself is embracing the power of the LLM that we used underneath the hood was it could extrapolate the idea of what is Europe and understood the data schema behind the scenes and say, like, oh, it has country name in it. I can list every single country name that's in Europe and create this query. So this will just enable people to create an actual quick query that otherwise would be tough to write, wouldn't be as quick to write in of itself. So the initial decisions I made when building the service was we chose to use AWS Bedrock. We evaluated a bunch of other things, but we chose to use AWS Bedrock because it is very easy to use, very programmatic useful options. There's multiple model options available. It enabled a fast time to POC and quick experimentation, and it's serverless. You're not running a server in the background, eating up time and money all the time, Another benefit was retrieval augmented generation, which is a technique used to enhance your prompts, using the knowledge bases that are built into AWS Bedrock was super quick and easy to use. And then the other benefit of choosing AWS Bedrock was moving to production requires a low level of effort because they have built-in guardrails that can protect you against a lot of things that you don't want users to be able to query against and stuff like that. And jumpstart with the industry-leading LLMs. And as a side note, training an LLM takes a lot of time and money and expertise that I personally, frankly, don't have. I'm not an AI engineer. And then the other thing is we have an existing relationship with AWS. So it's easier to take advantage of that than having to go deal with building up a relationship with another vendor itself. So the first version of this was making the minimal viable product. Nothing fancy, just prompt the LLM, then I get something working via API, they got something working in the UI. And here's just a quick prompt that I had. It says, you're a Druid SQL expert. Use the prompt to generate the SQL query. It's able to do some stuff, not great, but it works in a way. And then the next step on this flow was to actually make more basic prompt engineering things. So oddly enough, when you deal with an LLM and you're prompting it, you don't think you have to tell it to think, but actually telling it to think makes it actually give you better responses. Another thing that works as well is telling it to go step by step, giving it a chain of thought, and having to explain each step and show its work will actually improve its responses for you. The other things that I found is that you want to tell the LLMs to use tags and structures so that we can parse the output. It's parsing out essentially an essay. It's not easy to return back data you want if it's not easily grabbable. So that's why you want to use tags. And then also, you want to have structured data input in the model's preferred format. So in our case, we chose to use Claude, and Claude prefers using XML. And you saw better performance by switching from a JSON representation to XML representation in of itself. Once you have the general prompt down, the idea next is to actually have kind of a dev cycle. So you want to evaluate the generated SQL. We started out manually at first, but we moved to automation quickly because doing a manual checking of your generated SQL is very long, tedious, and not easy to do. So we built a test pipeline of itself, and that test pipeline has a bank of questions that we run against our functionality to ensure that we move forwards and not backwards. Otherwise, you can have regressions and not understand where you made that initial error, considering running this test bank is not a quick unit test in of itself. We emit the results to a Druid cluster for analysis. That's a bit overkill, but why not? I don't have that many questions, but I work at a Druid company, so might as well use Druid for itself. The test bank itself has consistent questions with multiple versions to help assess the prompt. I found that oftentimes my prompts could be very bad and not very correct, so I created the idea of having multiple versions of the same prompt that you can use to evaluate in of itself. And I'm able to run it via GitHub Actions or locally. This way I can test out my changes immediately or also push it to a production environment and test it out there. And then the other thing at the end of it is, after running through all these test prompts, you analyze the failures, find the patterns that you care about, see which categories in which they fail, and try to find out which ones you want to solve next using the LLM to turn the text into SQL. So you can see the wonderful diagram. You improve the text to SQL, you test it, you analyze the results and find the error pattern, and you keep going around that pattern itself. So after you have all these test bank questions, you need to evaluate the test run. But it's hard to evaluate a test run so it doesn't take up all your time. Not all queries generated are deterministic, and LLM will not give you the same response back every single time. So you can't check against the actual SQL query given to you. And also, the results back can be different. You can have columns in different orders. You can have other values given back to you. And some test prompts are also more open-ended, so it's not easy to test, where you end up with where you can't test A equals A directly. So as a part of this, I leveraged the idea of LLM as a judge. So we use the LLM to help us. So we take it, we have the LLM look at the prompt and the query and generate it and evaluate it, say, hey, this makes sense, this doesn't make sense in of itself. And then at the end, you always want to make sure there's a human in the loop to make sure it's working correctly, because you can't always trust the LLM because it can hallucinate. And then the initial evaluation showed it was capable of generating SQL, but didn't know about Druid SQL or knowledge of the table schema. Here is just pointing out some things that matters a lot for the actual text-to-SQL NLQ functionality is that you have to give it the schema, make sure it understands the ever-present __ time column in Druid, and time floor and aggregations and other things that make Druid very special. So here's just a quick example of me passing in a schema into the NLQ prompt that's useful to generate this SQL. The next thing after that I ran into from some of my test data, because it's kind of fun to do this, is try to trick it. I had some initial guardrails that I hand wrote into the prompt itself. It restricted query generation to only query data, but I was able to get around with some prompts. So for example, I had write a 3-paragraph college essay as a select statement, and it actually generated a select statement that more or less said, select how I overcame my fear of public speaking, which I'm doing right now as well. The other thing is AWS has built-in guardrails you can leverage to protect against abuse. They're tunable to different degrees in which you want to use, and it's super helpful and super easy to use that in itself. And then also you can add more prompting to your actual messaging to the model to prevent against further abuse like this. And then as part of the initial round, I had a set of test bank questions. But most NLQ test bank questions are for relational databases requiring lots of joins against multiple different tables and not really set up for OLAP or time series data. And I, as a Druid user, can come up with a quite varied set of questions I can use, but the way in which everyone uses Druid is very varied, very different, and it's impossible for one person to come up with every single set of test problems. So the next tool I built was a telemetry into this functionality itself. So I set up the implies field team with this functionality to collect data from them, so I can get more prompts on a reproducible data set and also preserve all the privacy for everyone else and just get it from our own company itself. So the few details I omitted were the prompts, the SQL query, if Druid thinks itself is plannable, and where the prompt is run. So if I need to actually take that data source and use it in the next test bank, I can use that. And the collected data is assessed and added to the test bank itself to run in the next test evaluation. So I ran into a bunch of other issues that I couldn't really solve directly with just making the prompt be better. One of the issues I ran into is that Druid SQL is not every single other SQL dialect. Most LMs are trained on relational database SQL, and Druid SQL can vary differently from that in of itself. So in order to get past that, I used retrieval augmented generation, otherwise known as RAG, to supplement the prompt. It allows the LM to actually get informative, authoritative data itself to actually enhance its prompting and enhance its queries to give you a better result. In this case, I just use AWS's Bedrock knowledge bases to more or less scan, web crawl the Druid documentation, and it worked great and just able to get that information in really quickly. And the other option I could have done is fine-tuning, but that itself is a much heavier lift and not within the goals of trying to get a quick turnaround time and getting this quickly. And then the other thing I ran into is, as part of the RAG, you need to be able to search for what you want out of the documentation, but the LM doesn't necessarily know about certain Druid concepts. So for one example, as people are moving towards away from multi-value dimension strings into array type strings, there's no real concept of that in the LM I found. So what we have is have the LM create a list of subtasks, like we abstract the idea up from beyond just like, hey, tell me about how to use this function that I know that exists in SQL generally and making sure it works correctly, to create a set of tasks and ideas so it can actually get that concept and get that information out of the authoritative knowledge base in of itself. And then the other thing that I ran into is stagnation of performance of the one-shot prompt. Performance here is, can the SQL query run and run accurately? So I leveraged a research paper called DIN SQL. I'm going to butcher the thing and I forgot to put in my notes, but it's decomposed something for generation of text to SQL. And this paper found a way to improve performance by decomposing the text to SQL generation into multiple steps. Generally, the first step is you come up with a minimal schema, you classify and decompose it, and then you use a different prompt for different classifications to generate it, and then you have the LLM self-correct itself. So for Druid, I had to create a minimal schema for the query. We pass it every single schema that Druid has, that the Druid has about the data sources. Classify it with easy, medium, hard. Then determine the types of queries that will be run and classified based against those, so like data sketches, lookups, aggregations, window functions, so we can ensure that we give it the best prompt, the most relevant prompt for the LLM to generate the correct SQL. And based on those 2 dimensions of classifications, we choose the right LLM model. So say it's easy and it's just a general select, we can pass it a very cheap and quick LLM model to generate the SQL instead of a larger, smarter model itself. And then at the end, we ask the LLM to judge and self-correct the query itself. The other issue I ran into is impossible queries. Some queries asked are essentially impossible to handle. They require multiple steps. They require introspection of the actual data. That's not something we wanted to build into the thing. We're just building a text-to-SQL, not saying, giving me which stock I should buy next year out of a data set. And are also use non-existent functionality and functionality that doesn't exist within Druid itself. These can be handled by classifying those queries and responding gently, saying that that functionality isn't available at this time. The other thing I ran into that is much more Druid specific is some queries use ambiguous terminology. Over time. If you're dealing with aggregations and you say over time, the LLM might give you something for where your data source's query granularity is generally day. It might decide, oh, let's look at everything per minute. That doesn't really make much sense. So there, we leverage the new functionality in Druid called the Druid catalog, which allows you to set a default granularity for your data source, and that's generally applied to your ingestions, to get the specific value and give you a much better query based on that. Another thing I ran into is data ambiguities. Many Apache Druid data sources and tables can be nonsensical names and also nonsensical column names. The LLM is actually very good at figuring out what those are. So in this contrived example I have time, I have UID, I have AMT, BNN SKU, and CST, and the data source is DLY_ord. I know the LLM will likely be able to figure this out, but I've seen things that are XPIE, and there's not really much context for stuff like that. So the other thing there is we also chose to leverage the ability of Apache Druid catalog to improve this by allowing users to specify data source and column descriptions in case they want to leverage the actual NLQ translation functionality in of itself. The other concerns that I found with this that we're not addressing in MVP is latency. The whole point of this was to create actual SQL to be able to run. If it's a bit slow, it's not the worst thing, but it's something that I do have in my mind of how to handle it. The other thing is cost. Generating queries can be expensive, and we need to choose the appropriate model for each task. Even with the decomposed SQL queries guiding it, that involves multiple LLM calls to the LLM itself, which can slow it down. But you can, like I said, choose the more appropriate model for faster speeds. And then the other thing is actual query speed. We view this as a SQL starting point, not optimizing your SQL query or optimizing your text-to-SQL in of itself. But with the telemetry we built, we can collect the data about the query speed to classify the prompts in terms of their speed. And so we can make improvements to this in the future as time goes on. The next steps that we're looking forward to doing in terms of this text-to-SQL functionality is move to a conversational model to allow for better UX. This will allow a user could suggest hey, I was actually thinking more about this column instead of the column you chose for me out of the schema that you looked up. Fine-tuning the LLM, be able to make the functionality be a lot better without having to necessarily use RAG. Agentic workflows, which more or less lets the LLM go ham and choose what it wants to do and figure that out. But I wanted something fast and quick and didn't really want to have to figure out the black boxness of that. and then robust guardrails against abuse so this can be productionized for people to use. The other functionality and that's related, but I'd love to have in there would be, you have a coworker, they send you a SQL query to run, you're like, I don't know what this does, I don't understand how it's working, or you get it off Stack Overflow. So this will allow you to actually paste the SQL query in, and the LLM will be able to explain to you what it's doing and things like that. And then also SQL queries for ingestion into Druid. My acknowledgements are, I'd like to thank the people on the screen and anyone else who I forgot to list. I think I forgot to list my coworker Zach, who's working on the catalog functionality for Druid in and of itself.